Hello everyone, my name is Damilare. In this lesson, we'll be looking at the topic alkanoids. Another name for alkanoids is esters. Esters are formed when alkanol reacts with a carboxylic acid. Other product of alkanoids is water, and the process is called esterification reaction. As you can see the reaction here, this is ethanol, ethanoic acid, and this is the product ester, ethyl ethanoate, and water. So that reaction is esterification, where H2SO4 is the catalyst. How do we go about this reaction? When you look at your ethanol, just pick the OH. Just like a base will produce hydroxyl, acid will produce hydrogen. So take the hydrogen, take the hydroxyl, that will form water. Then the remaining C2H5, put it at the back of the CH3COO to give us the ethyl ethanoate CH3COOC2H5. And as I said, the forward is esterification, so the backward will be hydrolysis. Meaning if we add this water to this ester, it gives us ethanoic and ethanol. Now the functional group of ester is COO, meaning anywhere you see ester, you see COO appearing there. While the GMF is RCOOR, meaning that Q will be on the left and right. We can also use this formula CnH2nO2 for our ester, but always start from 2. Anywhere you see N, put 2. So let's look at the IUPAC name of ester. The first IUPAC name, if I put 2 here, that will give me C2H4O2. So as you can see it in our molecular formula. Then for structural formula, always start with the functional group at the center, COO. Then on the left, we put our H. On the right, we put another Q. Because looking at this formula C2, it means C must appear twice. One is already here on the left, one on the right. Then the H4, meaning 3 will cover this C here, 1 H will be on the left, that's 4. Then the O2. So as you can see, the O is above and below. They always know that double bond must be around oxygen because the oxidation number of oxygen is 2 minus. So that is for the first one, and the common name is methylformate. Methylformate, because here we have methyl methanoate. Whenever you want to name your ester, you start from the right hand side. So and as you can see on the right, there is methyl CH3. So and on the left, 1 carbon meth, so that makes it methyl methanoate. So and anything meth is also called form, so methylformate is also for methyl methanoate. Then we move to the next one. Remember we started with 2, so we move to 3. If I put 3 here, that's C3H6O2. so this will give us C3H6O2 as you can see it here. Then how do we write the structural formula? Always start with the functional group COO at the center. Then on the right we put 1C, on the left extra 1C to make it 3 carbons, 1 2 3 from this formula. Then the H6, we surround this C with 3 hydrogen, surround this one with 3 hydrogen, that's 6. The oxygen is 2, 1 above, 1 beneath. So looking at the arrangement from the right, because we always name from the right, so it means there is 1 alkyl on the right, that's methyl, but on the left 2 carbons, that's eth, so that's methyl ethanoate. So and anything eth is acets, so meaning methyl acetate. So that leads us to the sources of esters or sources of alkanoids. So where can we get our alkanoate from? So you can just use the mnemonics 3FS, meaning FFF and S, 3FS, meaning we can get ester from fat and oil, from flowers, from fruits, then from stearic acid. As you can know that each of these things has their own special fragrance. So that fragrance is the ester. Oil has its own fragrance, flower has its own fragrance, fruit has its own fragrance. For example, banana, there's a smell from banana, so which is ester, and the name of that ester of banana is pentyl ethanoate. If you want to remember, write small letter B for banana, turn it upside down, it becomes P, pentyl ethanoate. Orange, pick the letter O, gives it octyl ethanoate. So that leads us to the uses of ester. What do we use ester for? You can use the mnemonics. Please find PC, that's personal computer for slave. The P means paint, so there is a smell in paint, which is ester. Then another one, F we can remember with flavor, meaning there is a flavor we use for food, that is another ester. Then the next P is perfume. Perfume gives a smell, which is also ester. Letter C is cosmetics, all these makeup materials, so they also have smell called esters. Then the next one is S, solvents. We can use ester to dissolve, so as a solvent to dissolve cellulose nitrate. Then L, lacquer. Lacquer is a gloss finish in furnishing. After making your furniture, you try to furnish it, make it shine. Something that looks like oil will be used to polish the surface. That's L. Then A, adhesives, like all these top bond, all this gum. So they have their own special smell, which is also ester. Then V, varnishes. Varnish is a protective coating on wood, meaning after making your furniture, you try to furnish it against all these pests that eat wood. So that's V. So the next thing we look at is how do we prepare ester, ethyl ethanoate. To prepare it, take your ethanoic acid slowly. You mix them inside this round bottom flask, and there should be a bait, that's a warm baiting container. So you heat the warm baiting container so that the mixture of the ethanol and ethanoic acid will give us ethyl ethanoate, but it will be impure. Since it is impure, you use sodium carbonate and a separating funnel to purify that impure ethanoate and separate the impurities. But take note, while doing the baiting, the heat baiting, the temperature should be 150 degrees centigrade. Now, we also look at physical properties of ester. Physical properties of ester. How will you remember? Just take CV and BOS. BOS is like boss. The boss is requesting for CV, curriculum vitae. The C, we remember colorless. It means it has no color. The V, volatile liquid. It means it can dry easily. The B, boiling point of ester is 75 degrees centigrade, unlike that of arachidonic acid that is 11 heats. Then the O, odor, but taking that odor as smell, meaning it has pleasant smell. Then finally S, slightly soluble, meaning ester is slightly soluble in water. It will not dissolve completely, unlike that of arachidonic acid that is soluble in water. So we round up this topic with chemical properties of ester using the mnemonics ARAB, H, A, R, A, and B. The H means hydrolysis. Hydrolysis. What is the meaning of hydrolysis? That's adding water. So we can add water to our ester, so to give us ethanoic and ethanol. That means the reverse of esterification. How do we go about this? You pick your C2H5, separate it from CH3COO. Then from the water, pick only H. It means it will remain OH. The H you pick, put it here, it will form ethanoic. The remaining OH, put it here, it will form ethanol. The next letter is A. A means the alkaline, so it means alkaline hydrolysis of our ester. So this is an alkaline, that's the sodium hydroxide is an alkaline. So this sodium hydroxide as an alkaline, if I add it to this ester, it will give me sodium ethanoate and ethanol. So from here, we can just remember by separating CH3COO from C2H5. So first pick your OH here, add it to the C2H5, it will turn to ethanol. Then the Na, put it, replace it with this C2H5. So when you put Na here, so that will be CH3COO Na. So the Na is the sodium, then the two carbons here, they are earth, so sodium ethanoate. Then the other one here will be ethanol. Then the next one is R. R means reduction, meaning we can reduce our ester to ethanol, just like the arachidonic acid. How do we reduce it? We use a reducing agent called lithium tetrahydroaluminate 3. Use it to reduce. So this one has 4H. So the 4H, you add it to this ester here. So, and when you want to get your result, since it's going to give us ethanol, so this is your ethanol C2H5OH, so it means it will be doubled. So first pick your C2H5 from here, pick one O from here and one H, so that's C2H5OH. Then you also pick another C2 here, H3 here, take 2H from this place to make it C2H5. The remaining O and the remaining H here will form the second C2H5OH. Then the next one is A. A means ammonia, so ammonification, adding ammonia to ester. So to do that, it will give us amide. So once you know the formula of amide, that means it has alkyl, RCONH2. So from this amide, it means you first pick NH2 from your remaining H. The NH2 you picked, you bring it beside the CH3CO to give us CH3CO NH2. So the remaining ones we have left will be C2H5 here, one O here, then the remaining H, that's ethanol. Then finally B is for burning or bright flame, meaning when we burn or combustion of this ester, always know that there's always CO2 and water in most of the organic compounds when we burn, when we do combustion. So meaning, since it's going to give us this, you now count how many C do we have on the left. 1, 2, then plus this 2, that's 4. So because of that, we had 4 to the right here. Then the H, 3 here, 5 here, that's 8 hydrogen. So since we have 2 here before, we have to add 4 to make it 2 times 4, 8. Then finally the O we have here, we have 2 plus 2, that's 4. Since it is 4, we come to the right. Remember, we have put 4 here already. 2 times 4, that's 8. So but here the oxygen is not yet complete. So if we put the 4 here, so it means 4 oxygen. 2 times 4, that's 8. 2 times 4, 8, plus the 4, that's 12. So meaning that the 2 oxygen here plus 10 here, we have to put 5 here to balance it. So thanks for listening.